Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts entitled as land use, land cover. Land cover refers to the physical material on the surface of the earth such as water, vegetation, bare soil, or etc. roads, asphalts. Land use describes how people utilize that land such as recreational purpose, residential purpose, industrial purpose and agricultural purpose. For a civil engineer point of view, land cover data which is collected by using the remote sensing tool which provides the physical constraints of site. On other side, land use data which is collected by using the GIS tool which provide the socio-economic context needed for zoning and infrastructure demand forecasting. Land use land cover analysis studies how land is utilized. We have to keep the objective in front of us as a civil engineer. We have to monitor the changes on the existing land patterns or existing land parcels by classifying that whole land parcel with respect to the satellite imagery. With respect to that imagery or the way we have to collect the imagery by using some multi-temporal and thematic mapping. So the urban planning and environmental conservation, which is the main application of that land use land cover analysis, which supports the sustainable development or which provide the opportunity to the policymakers to integrate the existing policy or to frame a new policy for the society. GIS is used to for that accurate land measurement and record management. We have to provide the objective to digitize and maintain the land ownership data for the sake of our interest or for the forecasting development, where integration of survey data with respect to the existing GIS map will be more important. By using that high precision and easy retrieval of data, we can integrate the existing survey data by using that remote sensing and GIS tool, where land cover or the forecasted land cover land use or forecasted land use will be monitored. In the land record department, land registration, dispute resolution, there are many applications are available by the civil engineers. They are using or they are working on the same, which improves the transparency in the land administration and land records. The physical material, which is asphalt, which is on the left side image, and physical material is forest is also there. At the second part, land use, function of state park, function is that commercial zone and function is that commercial zone which is in orange color, then blue color water body is there, and in green color state park is there. Likewise, a forest is a land cover, a state park is a land use. Now if we have to classify the framework of the existing land surface, then we have to divide that whole existing land surface with respect to some zone or some level. So level 1, level 2, level 3, likewise we have to divide. Here we are focusing towards level 1 classification framework for urban or built up land, which is data collected by the satellite imagery and in the first phase. Next, second phase is that we have to use the aerial photogrammetry for the dividation of that whole satellite imagery of the built up land or the urban zone with respect to some nomenclature assigned, that is 11 for residential purpose, 12 for commercial and services, 13 industrial, 14 transportation. Likewise, by using that aerial photogrammetry, we are dividing that existing land surface or built up area. At the third phase, we have to use the ground survey and assign the nomenclature for the single family and the multifamily. Likewise, that nomenclatures are most important for the GIS point of view. If we have to use that whole satellite imagery as a GIS data model input, then that nomenclatures are most important for the comparison point of view. We can compare or we can highlight that residential area by any color, by any system or coding system from that urban built up land available or the land targeted. Here, with respect to that land framework, we can also check the area statistics from pixels to hectares. If we have 100% area, then that 100% area is divided into n number of zones like vegetation zone, water zone, barren zone, built up land zone, or many more. Now, the whole 100% area, from that 100% area, 30% area is for vegetation, 20% area is for water. Likewise, we are dividing that whole area and we are using that area for the sake of our interest, that development and the for futuristic development. So category is residential, commercial, forest, water, and area is in square kilometer. For example, commercial 15 square kilometer, which is of 10% from that whole 100%. Means the pixel counting method is most important, where we have to check that urban area by using that satellite imagery, which is the raster image. We have to superimpose that raster image into the 2D plane, just like we are covering or considering the whole earth surface is a 2D plane. So that means that the irregular shape which is accumulating n number of cells or n number of dots, we have to monitor that dots or marks that dot by using some colors, and we have to estimate the area using that grid overlay. So actual data and actual land utilization by using that area statistics completed by the civil engineers in urban planning. Now, urban growth and sprawl analysis. Sprawl analysis is one of the powerful application of land use land cover, where the outward expansion of cities into rural areas will be monitored by comparing that land use land cover maps from different years, just like for example 2000 year, 1990, 2000, 2010, 2020. So day by day the city will be existing and expanding. So that expansion must have to be monitored by using some curve layers from the whole city. Here pre 1990 is dark orange color, 1990 to 2000 is slightly orange, then 2000 to 2010 again slightly pinkish color, then again 2010 to 2020 again color which is assigned for the expansion point of view, that is population density, like population density. So by comparing land use land cover maps, we can quantify the rate of land consumption and identifying the direct growth or the direction of growth. This change detection analysis is essential for planning new roads, changing the existing roads, planning for new ring roads, expansion of water mains, expansion of sewage treatments, and the location of new public facilities. It helps engineers stay ahead of the curve. So engineers must have to be ahead to that development curve so that they can ensure the infrastructure growth which will be built where the people are moving. So one of the part for that growth analysis or the sprawl engine is that the encroachment on arable land and depletion of aquifers. Means as day by day the expansion of city is in picture, so that expansion must have the encroachment on the arable land, on the agricultural land or the land available for the agricultural purpose or for any purpose, and also depletion of water aquifers or water bodies is also in picture. So we have to be focused towards that arable land utilization and the aquifers which are available nearby to the city. Now moving towards population density, which is also the one of the model, here we have to check the exact increment or exact addition of the population in the area. Now if we have 100% area of any city, then we have to check the actual population density, where maximum, where it is minimum. Now density is calculated by using the total population, whereas upon total area. With respect to the civil engineer point of view, we are the policy makers or we have to utilize that policy which are made by the government, and we have to implement on site. Then we have to check where the population density is more, where the population density is moderate, where the population density is minimum. Likewise level, we have to check the available facility and we have to provide the social facility, or we have to forecast the activities with respect to that population density for the sake of society or the people who are living in that area. Each and every person who is living in that premises or in that area must have to satisfy their daily needs by using the availability of activities, or by using the availability of recreational spaces, industrial spaces, livelihood, commercial zones, etc. So the impact is that increased strain on infrastructure and resources means as population density increases, the area consumption increases. So if we are acquiring large area for large population, then it is more easy for the policymakers or for the administration to rule the government or to rule the municipal corporation activities. But on other side, if the land parcel is minimum and huge amount of density or population density is acquired, then there must be a impact on the resources, on the infrastructure, and many more. So with respect to that point of view, we can check the land use percentage or the urban composition. Most of the surfaces are soil and vegetation covered, and some of the surfaces are impervious like concrete, asphalt, or the any type of built up housing. So if we have to check the percentage by using the area of class or the society which is accumulating the area, or which is consuming the area from the 100%. Now this activity is also utilized for crucial stormwater runoff planning or traffic density or agricultural land coverage, etc. So the primary input for hydrological modeling is that where surface runoff is directly influenced by the land which is paved or urban land, or which is porous just like forest land. So it is also play a key role in transportation planning as different land uses generate different traffic volumes, different land use patterns uses different land use volume. By mapping of land use land cover, engineers can predict future utility needs such as water supply and sewage, increment in the water supply and sewage capacity based on intensity of urban development, which ensures that the land use land cover data is allows us to design infrastructural development which is proportional to the actual human activity on the ground surface. Now, suitability analysis is one of the characteristics of land use and land cover, where we have to check the optimum utilization for the maximum activities with respect to the topographical characteristics like slope, soil stability, proximity to roads, etc. The image itself suggests that the colors for their dense to light, high suitability to moderate suitability, restricted to utilizing. So the legends are assigned with respect to some color, with respect to some patterns, with respect to some codes. The primary data source for land use land cover analysis is multispectral satellite imagery, such as from satellite Landsat or Sentinel. That satellite imagery captures data across various wavelengths, allowing us to distinguish or differentiate between different surface materials based on their spectral signatures. For high resolution or high precision urban work, we might use very high resolution imagery or aerial photogrammetry for the same. For geographical information system, we combine this remote sensing data with auxiliary layers like cadastral maps and the census data to verify that actual use of land and actual cover of land. The overlay method, which is one of the method for the staking the data or comparing the data or extracting the data by using some layer technology or techniques, where GIS model is used that layers for their analysis purpose. So GIS allows engineers to stake different thematic layers. That thematic layers may be of vegetation, soils, transportation, composite suitability, etc. This is nothing but a digital sandwich. From that digital sandwich, we can use one of the layer for the analysis in the QGIS software or in ArcGIS software. So spatial operations are by intersecting these layers, by combining these layers or by comparing these layers, engineers can identify the best locations for a new dam, landfill or highway that minimizes environmental damage. Smart city planning, which is also the futuristic land use, land cover, mapping and zoning, a specialized application of land use land cover analysis is we have to identify the urban heat islands. We have to identify urban heat islands means urban traffic density, urban population density, etc. Areas with high concentrations of built up land cover like concrete and asphalt, which absorbs more heat than rural areas like agricultural or some villages, leading to significantly higher temperatures. By interacting or by integrating land use land cover maps with land surface temperature data derived from thermal satellite bands, engineers can identify the hottest zone of city. This information is used to design green infrastructure such as urban parks, reflective roofing to improve the city's thermal comfort and reduce energy consumption. GIS based land use land cover analysis is a cornerstone of site suitability analysis. By combining that land use land cover data with respect to the topographical characteristics, slope, soil type, proximity to existing roads, we can identify that the most suitable locations for new residential or industrial zones. This analysis much more effective for making the colorful maps. It is a fundamental tool for evidence based urban planning. By using that remote sensing and GIS in civil engineering or in urban planning and mapping or in town planning, we can monitor the urban growth, we can assess the environmental health, we can use this tool for design the infrastructure or forecasting the infrastructure. We can monitor the change. As cities become more complex, our ability is to analyze that city development. We have to predict the land use dynamics, which is the key to building smarter, more sustainable urban environments. So, the remote sensing tool and geographical information system, satellite images, more reliable and more useful for the input point of view in the data models where we can extract the data, we can monitor the data and we can forecast the development. Stay tuned guys, happy learning.